Hi everyone, this is my voiceover of the series that I originally recorded for my overseas audience, and now, since there is some interest from my Silicon Valley community, I decided to quickly translate it. In this episode, we're using several new functions. These new functions are already in my project. Application path. This function will locate the folder with the database. Autosize columns. This function automatically aligns the columns to the widest content, either column headers or the cells, whichever the wider. Sort string array. This function sorts in ascending order, treating the string as natural numbers. Application path needs to stay in the main project folder, and all the other functions are in SubVI folder. I also added the folder with the database into the project. For convenience, I made these two folders, database DB and SubVI, auto-populating in the project. As you can see, if we open the menu, we can click Stop Auto-Populating. And the same for DB folder, but we need them to populate automatically. This means that any changes in the folder on the computer will automatically appear in the project folders. Also, this will be needed when creating the installation package, because during the installation we will be allowed to include these folders into the installer. You can also see that the two new SubVIs have been added to this project. I'll open the folder. Here we have the SubVI DB table create load, which we created in one of the previous videos. Watch it if you haven't seen that episode yet to learn how to create SubVIs. We'll also add a SubVI DB path and SubVI save DB table to TXT delimited. And today in this episode, we will create another new SubVI as well and walk through all of them. All these new SubVIs are needed for the next features or improvements, whatever you like to call it, like auto-sizing the table, database search, and saving the database into a spreadsheet file. These little improvements may look small, but they save hours later. The kind of hours engineers usually spend hunting for files they swear they saved somewhere. Let's open the VI. First, we need to copy it and create a new version DB provider 4. Add it to the project. We can collapse everything for now. Let's save and open it. So this is how we organize our project. For convenience, we put the database into the DB folder in our project. This is our database. It's called MES, Manufacturing Execution System Software. So we need to create the path to this database. For that, we'll use the function called application path. This function will create the path to our project regardless of where it is located. We place it on the block diagram and we'll use it for all future connections. More details about this function can be found in context help. Everything about this function and its creator is explained here in detail. For the output VI or executable installation directory, we connect application path to all structures, to the while loop, the case structure, and the event structure. Yes, we can connect it to all of them at once like this. And since we need database instruction in many places, we created SubVI and called it SubVI database path. We drag SubVI database path from the project into the DB refresh list event. This is what the SubVI looks like, and now let's see what's inside. We open it. Here's the front panel of the SubVI DB path, and the block diagram looks like this. I'll open context help. So what are we doing here? Application path on this diagram gives us the directory, the path to our folder. Here we added the DB folder. The name of this folder is written here in the string constant, and this is the folder where we store our database. We build this path using this function called build path. Here in context help, you can see its description. Build path creates a new path by appending a name or a relative path to an existing path. Next, we check if this folder already exists, and if it doesn't, we create it. This is done using the function check if file or folder exists. The next step is checking whether the database we need exists in this folder using list folder and for loop with conditional terminal. And if the database exists, this one mes.mdb, meaning it matches the name of our database, then we record it in concatenate strings function. Here it is. After that, we need to obtain the instruction for our database. This instruction is determined by the rules of the OLEDB. If these rules are met, the database will open for use with the Database Connectivity Toolkit. We call the resulting string the database instruction, DB instruction. Now, let's test how our SubVI works. On the SubVI front panel, we run it and get the instruction. Let's check if it's correct. Yes, everything is correct. This is the path to our database. This is one of those steps that looks boring, but without it, the whole system stops. Kind of like when someone forgets to plug in the power strip in a lab. Next, we go to the DB refresh list event, and here we replace the string constant, including the database instruction, with the SubVI DB path. We simply delete the constant and place the SubVI onto the error wire. Connect DB path to the DB tools open connection function and connect the application path program to the SubVI like this. Next, we go to the DB refresh table event, and here we need to do the same. Replace the instruction with the SubVI. Then we go to the global on case. Here too we need to add the SubVI, the database path, and connect it to our first SubVI that we created earlier, DB table create load, at the terminal called DB instruction. Next, we move on to programming the Autosize table button. On the front panel, we have two tables, one on the test station tab and the other on the database DB tab. Here are the buttons, Autosize, and here also Autosize. We'll go to the variables case, and here these two buttons are already waiting for us. Autosize DB table and Autosize test station table. We move them outside the while loop and go back to the event. Now we currently have 4 events before power, meaning after the last created case DB refresh table, we create a new event. Select Autosize DB table, place the boolean Autosize DB table and create a constant. Here we select wait for event. And now we add the new program already added in our project. It's called Autosize Columns. And we need Autosize table columns connected to the error wire. Now we create a reference from our table. That is, we are now connecting this button from the DB tab. Go to the DB table menu and choose Create Reference. Then we connect the reference to the input table reference of the Autosize Columns program. Then we do the same steps for the second table. If you ever resize the column 15 times to make it look perfect, this button is basically your new best friend. Next, from the variables case, we take all the buttons. Here I already have them prepared. DB search in DB, DB table list, DB table, DB search, DB table columns, DB sort num, DB rows, DB columns, and save DB table. Move them outside the while loop, go to the wait for event case, and now we create a new case. After Autosize test station table, add event case, choose DB search in DB, database search in database, place the corresponding boolean, create constant. And here we need to add a new name in the enum constant. To do this, go to open type default, edit items, insert, write DB search. And we need to move it down. Move down, so it's in the middle or at number 3. Close it and save it. Here in this event, we choose the DB search enum constant, then we connect the arrow wire and go to the case structure and add a new case. After wait for event, DB search case is created automatically. Here we place the enum, wait for event, and we start by creating a property node, DB table value, add the SubVI with the database instruction, SubVI DB path. At this point, even the enum is thinking, wow, we are really adding a lot of responsibilities today. Welcome to Startup Engineering. Everyone wears 5 hats. Connect all this and then add the next set of functions, DB tools open connection, DB tools select data, database variant to data within array constant to the array, list columns, and DB close connection. Add all of them to the block diagram and connect them to the error wire. Next, connect SubVI DB path to connection information of DB tools open to open the database. And we also need to create a property node from DB table. Wait, I got confused here for a moment. So DB table value is not here, but here. Okay. And we add one more property node here, column header strings. And also property node value change to write and connect. And in the beginning here, before DB tools open connection, we need a property node value from DB table list. Create property node value DB table list. Value connects to select database on the table input and to list columns on the table input. Column headers connects to list columns on the columns output. Next, we need to add concatenate strings. Add and connect it in this order. First string, create constant and write where space. Next, DB search, DB table columns. After where goes DB table columns. Then another string constant. Here we write like space apostrophe %. Then DB search string, and in the closing string let's type %, and apostrophe. And add a space before like as well. And connect all of this to select database function. Some developers say SQL stands for sometimes queries lag. With this setup, at least the logic won't. Next comes the matrix function. From array, choose matrix size. For matrix size, we'll need DB rows and DB columns connected and wired into database variant to data. Then we add search 1D array, connect the input 1D array to columns and to DB table columns. Then from the new programs folder in the project, from sort string array, choose 2D array sort. Drag it into the block diagram and connect it to search 1D array at column to sort on. And connect the boolean DB sort num to the sort numerically input. And the output 2D output array connects to DB table value. Like this. Check that everything is in place. Yes, it is. Okay. Save it. What's next? Next, for all this beauty, let's create SubVI DB search. We'll do it brutally and fix it later. So we take a SubVI DB path, DB table list, all property nodes, move them down, all indicators like DB search, DB table columns, and these three, DB sort num, I'll move lower, DB rows and DB columns. Like this, so we don't select them when creating the SubVI. They won't go inside the SubVI. Select everything we need, everything that can go to SubVI. From the menu, choose Edit, Create SubVI. Now let's open it and check what we got. Let's use cleanup. Good, everything is in place. Where, like, these are already SQL commands. And here we rename this to rows. It should be rows. For some reason, change the name. I'll fix it. Here columns, here rows. Yes, correct. Save it in our SubVI folder under the name SubVI DB search. Okay, close. Creating a SubVI is like refactoring your brain. Suddenly everything looks cleaner and you wonder why you didn't do it earlier. Now, here we also need to rename the icon. Select delete and name it DB search. Okay, now let's fix the terminals. We need to add terminals. Add terminal and reconnect everything. On top, we disconnect this terminal, disconnect this terminal. These are all incorrect. Let's reconnect them all. So, DB instruction, that is our SubVI, goes on the left. Then the next connection is DB search at the top. Second, DB table columns. Third, DB sort num. Below we have DB table list. This is property node value. Here the next one below is column headers, property node. And the next is 2D output array. Save it and close it. Relink to SubVI. And I will just delete all wires and reconnect everything. So we place DB table list together with value and connect SubVI DB path to the new terminal in the SubVI. DB table columns, DB search, we place them like this, and boolean DB sort num. And on top, we connect DB search, DB table columns, and DB sort num. On the right, we have rows and columns. Wait for event enum, we move back, value goes here, column headers and 2D output array, like that. Then I move it slightly down and align and save it. Honestly, reconnecting terminals is the LabVIEW version of untangling Christmas lights. Necessary, unavoidable, and mildly character building. Now, let's see how many instances of DB path SubVI we have on our block diagram. Click on the SubVI, find all instances, and we see we have 4. The first is on DB refresh list, the second on DB refresh table event, the third on DB search case, the one we just created, and another one on global on in the case structure. And what can we do about it? We can optimize it by placing the SubVI only once at the very beginning of our process in the case structure, case initialize. We place SubVI DB path on the error wire and connect it to all cases and structures using shift register on the while loop. So now SubVI DB path exists only once, and everywhere we need it, we optimized and connected everything wisely like that. Next, let's add a new event, save DB table. It will be after DB search in DB. Add the boolean button save DB table, create constant as usual, wait for event, connect it with the database instruction. And here we need a new SubVI that we prepared. It's called save DB table to TXT delimited. Connect it to the error wire. And we also need a property node from DB table list. Create property node value. And we also need a local variable from DB table, change to read, and connect it to the input of the SubVI. VI or executable also connects to our SubVI save DB table to TXT. Now, let's look inside this SubVI. Here we create a report folder, report. If it doesn't exist yet, we create it using build path and check if file or folder exists. And if not, we create folder. I enabled context help. We can look at the details. Then we form the file name using concatenate strings, get date time string, search and replace string. The file name will contain the table name from which we are saving data, as well as the timestamp, date and time with seconds. So each file has a unique name. Since the time format includes colons and slashes, which are forbidden characters for the file creation, we replace slashes and colons with hyphens and spaces. We also create a pop-up message for the operator showing the directory where the file will be saved. And when saving the spreadsheet file using write delimited spreadsheet function, we can see the details in context help. It converts 2D or 1D array of strings, signed integers or double precision numbers to a text string and writes the string to new byte stream file or appends the string to an existing file. For this function, we need to specify the delimited character, which in our case is a comma. here in the string constant. So this is how everything works in this SubVI. Close it. Everything is ready here, and now we return db table list and db table into the variables case. Save everything. Now let's test how this part of the program works. Run it. I'll hide tabs and collapse. So the program is running. Here is the first Autosize button. Yes, we programmed it today. And here's the second one. db table list, we made it last time. If you haven't seen that episode, I recommend you watch it. In the previous episode, we programmed db table list, db refresh list, and db refresh table. So it's empty, yes, we click db refresh list, we get the list of tables already existing in our database. We select, for example, test station 1 and click db refresh table. The data appears in the table. To see it more clearly, we click the Autosize button. The columns expand and format. And here in db search, we can search for something. For example, we need index number 2. We want to find it in the index ID column. We select it, yes. Here all the columns are listed that exist in this table. We click db search and it finds all instances like this. And next we want to save, and file saved comes out in this format with the date, time and seconds. In the next episode, we will continue improving the state machine and programming all the remaining new buttons using the database connectivity toolkit functions. A reminder that the source code of this program for this episode can be found in the description to this video. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, click like and subscribe to learn more from upcoming episodes.